Hey, this is Mr. Grunz, and in this video I'm going to go over functions and function notation for our term review. To determine whether a function, you first have to remember the definition of a function. And the one that we've been using is that every input should have exactly one output. So if I look at this very first problem, I see for here that 2 is the input and that 2 is also the output. And that's actually okay to have the same input and output. We just want to make sure there's not one input that has multiple outputs. And if I look at the very next one, we actually see that that's the case. For both of these, I have 2 as my input. The first one has 2 as the output. The second one is negative 2 as the output. The problem basically is that if I give an input of 2, you don't know whether you should give me 2 or negative 2 as the output. So this is going to be a no. Okay? That's not all I have to say. I also have to explain why it's not. And I have to do so using the definition of a function. So I could say no, there exists an input 2 with 2 different outputs. And those are 2 and negative 2. Okay. So I've explained it's not a function, and I explained specifically why using our definition of a function. Second one here is a graph now. Same question though, is the following a function? Explain your reasoning. And I could look here, and basically it's the same thing as an ordered set of points, except for we have an infinite number of them. I could look at any one of these, like right there, and that's the point 3, 0. So there's an input of 3 and an output of 0. What I want to determine is if this is a function, or in other words, is there any point, are there any points here that have more than one output? You may have heard of the vertical line test before. Basically means if you draw any vertical line, is there anywhere in the graph where it hits it more than once? Because if it hits it only once, that means for that given input, so for right here an input of 1, there's only one output of 0. If you look all anywhere here, there's no vertical line I could draw that that would intersect it twice. So I would say yes, this is a function. And then I have to explain why using the definition of function. So yes, this is a function because every input has exactly one output. So there's functions. What basically you need to know is the definition of a function, and then be able to apply it to examples and explain why or why not they are functions. Alright, second one in this video is going to be function notation. You get this nice and centered here. Function notation also deals a lot with inputs and outputs, and here we deal with how those two are connected. You could see a problem like this. We have f of x is equal to 2x squared plus 5x. So we have our function defined, and then we want to find with specific inputs what would the output be. So if I want to find f of 0, that means 0 is the input. I put the input wherever x is. So I get 2 times 0 squared plus 5 times 0. So I substitute in, now make sure that I follow order of operations and evaluate this. 0 squared is 0, and 2 times 0 would be 0. 5 times 0 is 0. And then 0 plus 0 gives me 0 as my answer. Okay. I would really recommend that you organize your work here. Don't try to do too much in your head. Write out your thinking and make it easy to go through each step. For f of 1, I'm going to plug in 1 wherever I see x in this expression. So I get 2 times 1 squared plus 5 times 1. Here I got 1 squared, which is 1, and 2 times 1 is 2. I'm adding on 5 times 1, which is 5, and 2 plus 5 is 7. The final one on the left side here, f of negative 3. So I'm going to plug in negative 3 for x. So I get 2 times negative 3 squared plus 5 times negative 3. So negative 3 squared, watching negatives, negative 3 squared is negative 3 times negative 3, which is positive 9, and 2 times 9 is 18. I'm adding on 5 times negative 3, which is a negative 15. And then 18 plus a negative 15 gives me a positive 3. If I'm given a graph instead, this is just a different way of connecting the input and the output. So this first one, I have an input of 1. The inputs are the axis, so I look on the x-axis and I find, okay, 1 is right here. And that intersects the graph at this point. The y value of that point is y equals 1, so g of 1 is 1. For the second problem, I got g of negative 2. So I go find g of negative 2, right there. See where it intersects my function. It's right up there. And that is going up 2. 1, 2. So g of negative 2 is positive 2. This final one flips it around and asks, instead of what output does input give, we're given an output and we want to find the input. So I go down to negative 3 for a y now, because I'm starting at the output, which is right here. And then I'm going to go find, where is that? Hits it right there. That's at x equals 5. If you're not sure about this, you just check at the end. If I do g of 5, I go out 5, you go down, intersects the graph right here, and that's at negative 3.